use the table below to answer the questions. Okay, we have a two-way frequency table. The reason it's called two-way is because you have your characteristics and your responses. What is the joint frequency of 10th graders that prefer dogs? Well, to be able to understand that question, you have to know what a joint frequency is. The joint frequencies are each individual element, like 3 is a joint frequency, 7 is, 49 is, 36 is, 53, 64, 22, and 10. There are 8 total joint frequencies in this table. So what is the joint frequency of a 10th grader that also prefers dogs? Correct, 64. You would just go to the 10th graders and then go over to the dog column, and there's 64 10th graders that prefer dogs. What marginal frequency is the largest? Well, what do they mean, marginal frequency? Right, the totals. Like, how many total 9th graders were surveyed? 127. Right, 127. How many 10th graders? 117. How many liked birds? 2. How many liked cats? 85. How many liked dogs? 117. And how many liked fish? So how many total students were surveyed? 244. Okay, so now that we've done that, we can answer which marginal frequency is the largest. And what is it? Right, I heard it back here. 9th graders and 127. Right, 9th graders is your largest total up there, because there were 127 of them and no other total is larger. Well, right, yeah. Okay, how many students in the 9th grade are surveyed? 127. How many students prefer fish? Correct. Determine if each statement below is true or false. More 10th graders were surveyed than 9th graders. False. That is false. There were 10 more 9th graders surveyed than 10th graders. More students prefer fish than birds. True. There were 32 students that preferred fish and only 10 that preferred birds, so that's true. There are more 9th graders that prefer cats than 10th graders that prefer cats. That's also true. There are 49 9th graders that prefer cats and only 10 10th graders that prefer cats. 36 10th graders. Okay, moving on. Use the following graph to answer questions 14 through 17, which obviously is not 14 through 17. 2 through 4. The graph shown represents the temperature each hour after sunrise. The line of best fit has been drawn. Write an equation for the line of best fit. Okay, they kind of like give you step by step. What is the slope? How do you calculate slope? What do you need? 2 points, right. So we'll choose this point. Our y-intercept is one of our 2 points. And then, let's see, this is a good point. So I'm going to write down the 2 points I chose. And remember, they're both x and y. Points are always an x and a y value. This was my first point, so I'm going to put a 1 on each one, and this was my second point, so I'm putting a 2. What are the coordinates of this first point that I circled? 0, 52. Okay, let's talk about how he got 52. If you notice, this line right here is at 50, this one's at 55. So the line in between them would be 52.5, right? Well, the line actually hits the y-axis a teeny bit below that, so we rounded down to 52. Please pay attention. What's our other point that we circled? 4 and 60, correct. So now that we have those 2 points, how do we use those to find slope? Okay, so obviously now that we know the formula for slope and we have our 2 points, we just plug them in where they go. So what goes first? 60 is the y2, so it goes first, minus, over, okay, and that becomes, and so that reduces, and that is our slope. Okay, now what is the y-intercept? 52. We had already, found that because we chose it as one of our points, but the B is where it hits the y-axis. Now that we have our slope and our y-intercept, what will the equation look like? Right. Okay, interpret the meaning of the slope of the graph. You can see that as the hours increase after sunrise, what's happening to the temperature? It's also increasing. So you could put something like, as hours increase after sunrise, so does temperature. And I'm just going to abbreviate temp for temperature because I ran out of room. Okay, so as hours increase after sunrise, so does the temperature. Okay, interpret the meaning of the y-intercept of the graph. Well, what is the y-intercept? But 52 what? Degrees. So, and what does that mean if that happened at 0 hours? Well, before sunrise, it was 52 degrees, right? Because 1 hour after sunrise, it was already up, it looks like maybe about 53 degrees. So before sunrise, it was 52 degrees. Alright, number 5. The linear regression equation for a set of data is y equals 0.32x plus 4, where y represents the number of hits a baseball player got and x represents the number of at-bats. Use the equation to predict the number of hits a player might have if he hits at bat 52 times. Okay, so they tell us to use the equation, so I'm going to go ahead and bring it down here. And then later in the question, they say use it to predict the number of hits the player might have if he is at bat 52 times. Where will I plug in that 52, the x or the y? How do you know that? Right, x represents number of at-bats. Well, at-bat 52 times, so that's an x value. So it's going to go right there. Y equals 0.32 times 52 plus 4. So go ahead and type that in. Okay, and what did you get? Right, and obviously you can't have 0.64 of a hit, so you could say between 20 and 21 hits. What? Okay, next page. The table below shows data gathered by a dairy farmer and shows the total liters of milk produced by a certain number of cows each day. Does this data follow a linear model or exponential model? It is linear. Now remember, that doesn't mean that it forms a perfect line. It just means if you plotted this data, the scatter plot would be able to draw, you would be able to draw a line of best fit. Let me show you an example of what an exponential model would look like. Okay, say that you started at 3. That might be what an exponential model would look like. See how every single time it's increasing by a lot more than the previous time? That's what an exponential function does, because think about it. Here's a straight line. Okay, so obviously the line is going to go steadily up, but it'll take a while to get to a certain height. When an exponential function curves, doesn't it go higher quicker than a line does? And that's because these y values are jumping by larger amounts each time. Okay? Does that make sense? Okay, so now that we've answered that, let's look at the next one. Label the type of regression each graph is showing. Okay, what is this type of graph? Linear. And then we kind of just talked about it. Which one of these is exponential? This one, the curve. Now, I know the other one kind of looks like a curve, but do you see on the left how it's starting to go back up? And so it's in it, like think about it, if we had kept plotting this way, wouldn't it have made a U-shaped graph? U-shaped graphs are called parabolas, and they are quadratic functions. So just remember, U-shaped graphs are quadratic functions. Alright, number 8. A State Highway Patrol Safety Division collected the data on stopping distances, which is shown in the table below. So they give you a table, and they want you to find the equation of the line of best fit. So what do you think we have to do first? Okay, but how do we do that with just a table? Put it in the calculator. Okay, so go to Stat, Edit, clear out anything there from last period. Okay, so in your X, in your L1, you're just putting 10, 20, 30, 40, 50. And then in your L2 is where you'll place all the Y values, which in this case are 15.1. Okay, once your data is entered, what do you then do? Well, remember, just for the linear regression, y equals mx plus b, number 4. And then calculate. And then there's your slope, there's your y-intercept. So we're ready to write the line. Y equals 4x minus 35.3. Now that we have the equation for the line of best fit, we can use it to answer part B. Predict how far it would take you to stop if you were driving 70 miles per hour. Well, where would the 70 be plugged in? The X. All you have to do is look at the fact that it's miles per hour and see that miles per hour was in the X values over here. So you would just do y equals 4 times 70 minus 35.3. And so how long would it take your car to stop if you slammed on the brakes at 70 miles per hour? Okay, so we'll just round that to like 245. 245 what though? No, we were going 70 miles per hour. This is how long it takes us to stop in what? What? Feet. See how all the stopping distances are feet? So this is 245 feet. That's almost the length of a football field. Football field's 300 feet. Because it's 100 yards, right? And there's 3 feet in a yard. So 3 times 100. Okay, match each correlation coefficient with the appropriate graph. Negative 1, negative 0.7, 1, 0.8. Which one would the negative 1 go on? Right, because that's the strongest it can get, and it's negative, so negative 1. So where would this positive one go? The last one. Then the other two are kind of common sense. It's a good thing one was negative, one was positive, because which one appears to be stronger, the first one or the third one? The first one, and that makes sense because it's the positive one, so it has to go over here with the positive one. But if I had had a positive or negative, that would have been a little tricky. But since it does, it makes it common sense. Okay, now turn to the next page. What does a correlation coefficient of negative 0.12 indicate about the slope and the fit of the line of best fit? Okay, so you tell me what this would tell you about the graph. What? Right. Well, this number is very close to what? Which means what about the correlation? No correlation. So even though the correlation coefficient is negative, which would indicate that the slope is negative, if you were just looking at a picture of this scatter plot, you probably wouldn't have been able to tell me it was negative because the points would have just been everywhere and it would have been hard to tell. That's why we can use our calculators to figure out exactly what it is. Okay, but like I said, that's very close to 1. That's very close to 0, which means the points would have just been all over the place. You wouldn't have been able to draw a line of best fit. Okay, what is the difference between correlation and causation? Correlation, I'll write over this way. Some of you should pay attention considering there's a test tomorrow. A change in one event implies a change in another event. Okay, so correlation is when a change in one event implies a change in another event. Causation is when a change in one event causes a change in another event. So like that example we just did a few minutes ago about as temperature or as hours after sunrise increase, the temperature increases, is that correlation or causation? Do the temperatures rise, are they caused by the hours after sunrise? Yes, I mean, think about it. When the sun rises, the sun causes the temperature to go up, right? Sometimes it's not always as much as it is in like summer, but when the sun rises, the temperatures will increase. That's causation. Okay, number 12. Which statement suggests causation? Let's just, instead of writing yes or no, let's just pick the one that best represents causation. So out of these four, when you study for a test, you will make a better grade. That's a little tricky. I mean, studying should cause you to make a better grade, but is it always? No. When you study for a test, your classmates will study too? No. When you carry an umbrella, it will rain? When you drive faster, you will get to your destination sooner? Yes. That's the best example of causation. Okay. This is all information that a German psychiatrist, Alois Alzheimer, he is the one who described the disease later called Alzheimer's disease in 1906. Okay, well, now they have been following people with this disease, and so in the year 2000 in the U.S. there were 4 million people with it. By 2010 there were 5.8. By 2020 there were 6.8, and so on. They want you to let the year 2000 be x equals 0. What do they mean by that? Like instead of calling this 2000, what should we put? 0. So if we do that for the year 2000, what should we put for 2010? 10. Because isn't 2010 10 years past the beginning of this research? Okay, 2020 would become 20, and then 2030 we would put 30, and then 40, and then 50. And remember why we're doing that? Because when we were doing those problems with years, it just didn't come out right, and so we renumbered it. Okay, so now that we have it renumbered, and those are our x values and these are our y values, we're going to use a graphing calculator to calculate the line of best fit. Since we already did one just like this, I'm not going to do it with you. I want you to take a second and find the line of best fit with your calculator. What's your slope? What? Okay, so we'll just put 0.2. And what's your y-intercept? So plus 3.5. Okay, now that we have that equation for our line of best fit, based on the data, what is the projected number of patients in 2075? So what do we plug in and where? Right, we're only going to plug in 75, and where does it go? The x, because years are x values. So you would do 0.2 times 75 plus 3.5, and then that'll let you know how many people are expected to have this disease in 2075. 18.5 people? That's all? 18 people? Million, right. Unless there's a cure before then. Okay, number 14, last question. Jeremy asked a sample of 40 eighth grade students whether or not they had a curfew. He then asked if they had a set bedtime for school nights. He recorded his data in this two-way frequency table. Okay, A wants you to first find the marginal frequencies. What are marginal frequencies? Right, so what is the total number of kids who had a curfew? No curfew? The total that had a bedtime? And the total that didn't have a bedtime? And what did both of those totals add up to? 40, which makes sense because he already told us that he sampled 40 students. Okay, so we did A. Out of those who have a curfew, what percent do not have a bedtime? 16%. This is how you would figure that out. You would go to curfew, which is here, but do not have a bedtime, which is here. That's 4 kids out of 25 is 0.16, so 16%. So out of those that do not have a curfew, what percent have a bedtime? How many kids fall in that category? How many kids don't have a curfew but then have a bedtime? 3 out of how many? 15, so that's what percent? 20%. I went to no curfew, because do not have a curfew, and then I went to have a bedtime. You see how those come together at 3? No curfew bedtime, and then added the total 15.